Welcome, everyone. Today, we're here to talk about setting sail in the Google Cloud with streamlined retail operations. My name is Alok Parikh, and I'm one of the founders of Striim, and I run product engineering. And also, today, I have with me Neil Chinta. And as you guys know, organizations today can better understand their customers and also optimize their operations by making data driven decisions. And a key requirement here is to enable real time data pipelines in hybrid cloud environments for both operations and analytics. So I'm going to call on Neil today to talk about Macys' journey for platform modernization and how they were able to set sail in the Google Cloud with Stream as the integration partner. So, Neil, over to you.
Thank you, Alok. Yeah, hi all. My name is Neil Chinta. I work for Macys Technology in the database group. So here, so today we're going to talk about one of the Macys use cases, how to do a platform modernization, and then how the stream helped us to modernize our platforms. And one of our key initiative is common services, and a bunch of common services we just initiated, and then so inventory, pricing, and catalog. And I'm going to talk about each of these topics in our next slide. So here, Macys use case. So I'm taking it as an inventory is our use case. So this is very high level diagram. So what I'm showing here is so where is our data? So what stream does for us? So then how are we leveraging it? So if you talk on the main points, so here our goal is to streamline orders and inventory management for customer experience and also profitability, of course. So also main goal of this use case is to adopt the cloud and also new business apps and achieve the real-time visibility so into the inventory data and also prevent any out of stock or inventory surpluses. So especially during peak holidays like Black Friday and Cyber Monday. So if you see on your right side, so this is our high level. So on the left hand side, you see the on-prem data, which is coming from mainframe and some other data sources. So that data will replicate using Stream to the Google. So here we are using a Google storage and Cloud Pubs up. So what we are using in the Google, and then I'm going to explain in detail in the next slides. So what are our drivers and benefits here? What drives us to do this? We need a single source of truth across multiple domains. So what is single source of truth? So because we have many databases like any other shop, we have DB2 running on mainframe and Oracle running in different location, and then each database and each type has its own data, and we need a single source. So that's one of the major drive to go for the stream, and also so the second one is to reduce the mainframe maintenance and license cost, of course. So there's operational cost of the mainframe and speed the market impacted data, so residing in multiple different systems. So what does that mean is we have data residing in multiple databases, and then if you need to fast develop the application, so you need to reach out to the different applications and the different areas to develop your application. Now we are making everything to single source, and then everything is available in the Google Cloud. And also we want to make sure the different customer experience across different systems, because we don't want a customer feel in the online, customer feels differently in the store. So that's the main motto of omnichannel. All the customer face the same experience. And the finally, but not last, so this is the inability to sunset an existing legacy systems. So some of the legacy systems, if we need to sunset, so we need to migrate the data to some other place like cloud. So this stream is helping us. So this is overall architectural diagram. So it's still very high level. So here I'm going to take a little longer time to explain what we are doing, and so what we can expect from here. So if you see on the left side of the diagram, that is our Macys on-prem data centers where the data exists. So we have inventory data is exist in the mainframe DB2. So DB2 and mainframe. and also Oracle databases. So that data is replicating using Striim to the GCP cloud. So that is a cloud spanner and also PubSub. So what Striim does here, right? So Striim runs an app that will read the source data. So Striim app contains multiple tables, one or many tables, which contains, so it reads the source data and apply at the target. So you can call capture and apply. So you can call extract and push. So that's what Striim is doing right now. So if you focus on the middle part of the Striim, we're calling as a VM, and so it's supposed to be VM1 and VM2. So but those two, so we're running two VMs in the GCP. So we are running two VMs because that's for high availability purpose. So if an app runs in these VMs and one VM goes down for any reason, for the maintenance or anything, apps automatically fail over to other VM seamlessly, and then we don't see any impact. There is no business impact. And so that's the reason I would recommend at least two VMs for the Striim cluster to minimize any outages. So Striim cluster is running in the GM, so in the GCP VMs, and then that data is pushed over to the spanner and also PubSub, and also it can do the BQ. So, but advantage of Striim is so it can apply all three or all two at the same time. So you don't need to depend on each other. So now, how are we doing this? So Striim, so on the on-prem, we're already running a Golden Gate. So Oracle Golden Gate. So the Golden Gate trial files. So Striim has the ability to read the Golden Gate trial files and then convert into insert, update, delete at the target side. So that's the one thing. So and then if you see those options like online migration phases, so there we mentioned two steps. One is initial load, another one is log-based CDC. What is initial load? So when I create a new table at the target location in the cloud spanner, so the table is empty. So we take the source data, so it's like a flat file. So the Striim app can read a flat file and then it apply like all inserts into the target side. So let's say, so if I do at the time T1, so I took the flat file from the source and then I apply all the data into the target. After 2 hours, time T1 plus 2 hours is time T2. So time T2, both source and target are in sync. So, but what happens, the changes are happening between time T1 and T2 because this is like a flowing river. So data flow never stops. So what we do is, so we take the time T1 minus 5 minutes. So go back to the time and then we run a real-time CDC, so using Striim. So we're going to have a 5 minutes overlap, but we don't miss any data. So that data will apply. All the duplicate data happens at the target side because that data might exist because of that 5 minutes, and then spanner will ignore it. So after catch up the real time, so then at time T3, both source and target are near real time. So that is very critical for our business. Whatever happens, changes happening at the source databases in the DB2 mainframe or Oracle, the applications are using, so the customer is accessing data using GCP apps, using Google Apps. So they should get the real data and the real time. So that I call like a near real time. So in our shop, so when we did this from source to target, it takes 200 to 300 milliseconds. So when you talk about this, you need to talk about the network speed. You need to use a lot of tuning parameters. So each shop is different. So, but that's what we achieved. So that's one of the major requirements for us. So here I'm going to talk about why Cloud Spanner, because we have many databases, and so we have so many options. Why Cloud Spanner? So we need a consistency of the inventory data from source and target. And also, so the accessing data is supposed to be faster. So we have so many databases, everything has its own sweet time. So Spanner stays on top of it. So then when you look at other options, so Spanner fits our requirements. And also most importantly, as a DBA, as a database person, I one of the requirements is high availability and disaster recovery. So by definition, Spanner can span multiple regions, so that will satisfy multi-region, so that satisfies the disaster recovery. In case one region goes down, other two regions can automatically pick over. And also high availability. So one region goes down, other region is always available for us. But also transactions can be accessed from anywhere, so across the globe. But for us in the Macys, we say across the United States. Some can access from Chicago, some can access from North Carolina, some can access from Texas. And if I go to the third option, so that is a relation system. So this is also one of the requirements. So we are looking for. So relational, because all our source databases, all our transactional source databases are relational systems. So it's easy to transform the applications and systems from source to target. So if you have the similar or same kind of support. So this is full-fledged relation system, Spanner. So like I mentioned before, so this is the near real-time data responses. And the response are faster. And then so data sharding will happen in the Spanner. So that also meets our requirement. So the last point is need for ability to scale the meet spikes in demand. So this is one of the key requirements for a retail industry, because retail business is not same like any other day if you compare with Black Friday and Cyber Monday. Those peaks are very high. So Spanner is easily scalable, horizontally scalable, and so during the peak time. So that solves all our capacity issues and also user experience during holidays time. Next. So this is the architecture wise Striim. So we have many replication tools available. So in the market. So why Striim, right? So Striim has a highly available real-time replication system. So I can say near real-time replication. And also Striim has proven the low latency end-to-end replication. So that takes milliseconds to reach from source to the target. Like I mentioned before, so that is very critical for our business. And need for enterprise grade features like high availability, recoverability, ability to handle volumes and velocity. So we talked about high availabilities, that is for requirement for any tool or any process we use. And also ability to handle value and velocity. So this is again critical point for retail industry. When you see during holidays, this is a very needed point. So because our volumes go up, our speed goes up, a lot of transaction goes up. So Striim is supporting that. And these requirements also lead to the need for CDC solution. So we have replication, we have so many ways, but Striim works on the CDC. So that is a change data capture solution, so which is very proven technology. And also it's fast, and also it won't put a lot of stress or resource constraints at the source level. And the next one is need for ability to write multiple targets. So this is important too, because if you're publishing your data to the Spanner, and then same data may need to consume by the pub sub and also BigQuery. So you don't need to depending on the data to commit on the Spanner, then write it to the pub sub, from there go to BigQuery. Now the Striim one app can run in multiple targets. Sometimes all these targets can use for different use cases, but we can achieve with one app from the Striim. So that's another added advantage. So the final point is complement an existing investment. So what does that mean? So that means So we already invested the money on, I'm using Golden Gate. So Golden Gate is already extracting the data and then replicating to different databases. So that's already, we already invested the energy and money on it. So now Striim has the capability to read the Golden Gate trial files, which which is complement existing investments. So what does that mean? So so here at Macys, so we are already using a replication tool, so Golden Gate, so Oracle Golden Gate, so which is replicating data from the source database to the target databases, from IBM mainframe to the Oracle. So Striim has a capability of reading Golden Gate trial files, and they transform the data or replicate the data into the GCP Spanner, PubSub, or BigQuery. So that's how we just achieve the process. So without investing another CDC process or like MQ kind of process. So this just complement the existing investment and also efforts. So that helps us. So that conclude my presentation. And so I know this is not completed. This is not complete picture. You may have some more questions. If you have any questions or if you need to understand more deep how we did it, what we need to get it done, so I'm happy to answer those questions. So thank you. I'm just hand it over to Alok.
Thank you, Neil. Thanks very much. And particularly, I wanted to mention a couple of points. One was, of course, that during peak period when you guys had the 7,500 transactions per second, the end-to-end latency to keep the solution real time with 2 to 300 milliseconds, as you pointed out. I think that was really, really, really good for trying to modernize. And the other part, of course, was leveraging the existing investment. And I was the CTO for Golden Gate. So I'm happy that you were able to take a Stream, which is sort of a next generation platform, and complement that with your existing investment. So with that, I'm going to get into the details of the Stream platform itself. As you guys, as Neil pointed out, there's multiple solutions that Stream enables. At a broad, higher level category, there's cloud adoption, hybrid cloud data integration, and in-memory stream processing. So let me step into each one of these. So Stream is a next generation platform. What you're seeing here is a layout. So on the left side, you have what I call your on-premise systems. These could be your current systems, your legacy systems, and they could also be your best-of-breed applications that are running on some other cloud. And on the right-hand side are the newer endpoints. So as you're modernizing your own business, as you're introducing newer systems, be they be cloud-based relational database as a service, or NoSQL systems, or storage systems, or analytic systems, oftentimes you want to bridge this gap. And one of the key things is, if you take a look at trying to keep things consistent and real time, traditional technologies don't always meet up to that goal, and there's several reasons I'm going to share. Okay. So the way to look at and interpret this slide is going from the left to the right. You need a next generation modern platform that allows you to deploy these solutions. And with that, there are 9 different flavors. I don't have the time to go into each one today, but I certainly want to touch on a few of them, which are relevant to what Neil talked about. So the first one is cloud adoption. So these have to do with, today you might be deploying your existing database systems on premise, and you want to simply migrate to the cloud because you want to take advantage of, let's say, a database in a managed fashion to lower your costs, to make it a lot more manageable, as well as to achieve the economies of scale from a compute perspective, a storage perspective. So that migration, how do you do that without interrupting your own business operations? And one of the very interesting solutions here is to keep your current application, which is running against your legacy system, up and running while you set up a parallel system in the cloud. And so long as you're able to set that up and keep the two systems synced up and concurrently running, then at some point you're able to transition over your application onto the target site. So this is what I mean by the one-way migration. Um, More interestingly, in the case of the use case that we just heard about, what they wanted to do was take a legacy system, in this case a mainframe, and take a lot of that data and move that into a modern system like Cloud Spanner. So when you do that, then you need to be able to again replicate that data. So that's the replication scenario. And similarly, there's also requirements that come up as you're trying to distribute your data. So you also saw that there was a in Neil's architecture slide, there was a Google Pub Sub endpoint. So that's a data distribution use case. As we try to liberate our data, as we try to modernize our applications, different parts of an organization have their application development teams, their data scientists, their partners, and they all want to have access to this data. Traditionally, this has been problematic because it is very expensive to collect and ingest the real time data that's going against a very mission critical system. And that is one area where the overall solution of doing a one time initial load followed by a change data capture allows you to effectively meet that requirement. Okay. So just generalizing forward, I'm going to go a little faster here. A generalization of the previous solution category is the hybrid cloud data integration. So this has to do with the fact that you may want to do not just a one-way migration, but have do a kind of a synchronized migration where you're running a system, let's say system A on premise, you're replicating it to system B, then you do some testing on system B, possibly migrate a few users, do a reverse topology where the data is coming back into the legacy system from the cloud-based system, and now you're synchronizing these two, and ultimately at some point you're going to pull the plug on one of them. Real-time data integration, um, big data integration. A lot of you are concerned with doing data lake type of projects where you're trying to take advantage of cloud-based storage systems. How do you get data into those tiers? So that's the second category here. And finally, the third one, this is truly the gateway towards digital transformation. So how do you deploy next generation advanced, very thin apps so that they can be deployed almost in a microservices fashion. Just to give you an example, as you're moving the data, if you're trying to count up things to make sure that operationally things are adding up, or if you want to alert on them if things are not what you expect. So these are the what I call the streaming applications that can be also deployed to deliver to the business the ability to monitor the operations very closely, as well as if you want to get any insights into the data specifically. For example, let's say if you're talking about order data, am I exceeding the number of orders within a given time interval, and should someone be alerted in the journey of? Now you can always do this by writing an application on the target endpoint, for example, in Google Spanner. But for real-time purposes, oftentimes we have found that people may want to do that in the pipeline itself. Okay, so that's this third piece. So our focus is really on customers like Macy's, and it's typically the global 1,000 types of customers. Typically, these customers have a very, very strong requirement as far as scale is concerned. So their data volumes are rather large, and they may range anywhere from order of tens to fifties of terabytes to let's say as low as 50 gigabytes. It doesn't have to be, but typically we see that the stream solution is being adopted in these kinds of environments. And the one fundamental thing that I really wanted to call out was oftentimes there's a reluctance to modernize because there's an impact to your actual application. So let's say your CRM application or your core banking application, retail application, inventory management application. So how do you then modernize that system by making the actual technology that's moving the data non-intrusive to the functioning of that application? That's really where we focus on. Okay, so why do traditional data integration technologies fall short here? Okay, and there's a number of different reasons. So number one, they often are batch oriented and have a job mindset, which means that typically you run some sort of an ETL job, and then that gets done, and now you have taken data that was different from last night, and now you move that into the target system. This is sort of uh, can be done nightly, but that doesn't give you real time data. So that's really one fundamental challenge there. Number two is just lack of support for data streaming. So if you wanted to give real time visibility and you're operating off of a reporting system that's reflecting data as of last night, then there is no possible way in which you could do what Macys was able to do, which was to deliver consistency across a system like Spanner. Number three, scalability limits. So you want to have a system that can scale up with your volumes. So to that end, Stream can is a distributed platform that can scale horizontally. Number four, and this is a very innovative thing we have done in a traditional data integration stack by adding capabilities like data validation. It's one thing that you move a finite amount of data and you're done, and now you can do comparisons. It's another where the data flow will never stop. It's going to, on an ongoing basis, keep moving. And so, how do you ensure that the source and the target systems are behaving as you expect them to behave? So, that's this whole area of data validation that we have added into the platform. And lastly, if you wanted to incorporate, advanced things like machine learning, your own models into the pipeline, those are also interesting things that customers want to do, and traditional integration stacks fail to accommodate for that flexibility that the platform desires. So within Stream, what we've done is, we made the provisioning, the designing, the deploying, the monitoring of these pipelines very, very simple. And the way you do that is by using the flow designer, which allows you to connect to a number of source systems, and you can design your data pipeline, and then you can deliver that data into a target system. So in this case, what Neil talked about was there would be a DB2 or an Oracle Golden Gate or an Oracle, say, system on the left side. On the target, you would have a system like Google PubSub and Cloud Spanner. And you could move the data. And along the way, the interesting thing is that you are able to do SQL based processing on that data. So you can literally take a look at a record and you're able to filter on that. You could have a very wide record format, like with 400 fields, and you could say, I want only 80 of these fields. You could transform that. So if you had personally identifiable records, you could mask those along the way. You could do aggregation by running SQL, doing a group by, and condensing the record and moving it to a target system. You could enrich the data, and you could also correlate the data. So these are the capabilities. I don't have the time today to go deep dive into each one of these, but for those of you who are interested, please reach out, and we can certainly help you with those use cases. A core differentiator is the ability to do change data capture. So this is something that I highlighted earlier, that without causing disruption to the mission critical application that is running, we want to be able to make sure that the changes, the inserts, updates, deletes that are occurring in a transactional fashion on your source system can be captured and applied in a transactionally consistent way onto the target. So this is the ability to change data capture, and Stream supports a number of different databases, including your popular relational databases, either running on premise or in the cloud. Okay. So as far as your overall journey is concerned, in terms of modernization, in terms of digital transformation, in terms of just getting to the cloud, specifically with Google, what we've seen is a number of the endpoints like BigQuery, Cloud PubSub, Cloud SQL, Dataproc, Cloud Storage, and Spanner. Stream is being used to deliver data into these endpoints, and along the way, you could try to reformat that data or deliver it as is, for the consumption ultimately from these endpoints. And so we really simplify the cloud data movement. Okay. So with that, I'm going to give you a 2-minute demo of what Neil talked about. So let me go ahead and play that. So what you're seeing is the browser-based interface, and there are two separate apps here. Let me jump into app one. So this is one of the pipelines. The top part of this is showing you that we're doing an initial load from an Oracle system, and we are going to move that into spanner. In this case, it's the line items table. Okay, you can see that there. And we're going to move about 100,000 records here. So let me go ahead and deploy this app. Okay, and once I deploy it, there's a preview capability available, so you can see the data live. Let's ensure that the line item table doesn't have any records in it. So let's go ahead and start the Stream app. And you can see now that the data is being moved. You can see the records. If I go to the monitoring page, I can see that so far I've moved about 86,000, and now I've ingested about 100,000 records. And ultimately, there you go. I have transferred 100,000 records. So if I come back and query, you can see that I have 100,000 records in Spanner now. Okay, so that was the way in which you achieve the initial load, followed by the change data capture. So in the change data capture side, you'll notice that there's a similar pipeline. And now, in this case, I'm doing this against the orders table, just to for the ease of use. Once I start this application, we'll use a Java application to go ahead and generate some workloads. So let's first make sure that this table also has no records. Okay, let's start the application, generate some live data against this table, and then I'm going to go ahead and query the orders table. You can already see that as soon as I started generating the data, I was able to see that in the Stream platform. And then finally, let's query the spanner system, and you are seeing that there's live records there, right? So I just showed you both the initial load and the change data capture. And finally, you can actually also go to the monitoring page, and there's all kinds of gory details available here as far as events in, events out. You can see the 100,000 records, and you can get a lot of the cluster related, the node related, the app related statistics here. Okay, so that was a very quick demo. So with that, what I wanted to do was just quickly ask Neil about maybe some of the challenges and the lessons learned as they delivered the solution using the Stream platform. So Neil, if you could maybe help our audience with that, that would be terrific.
Thank you, Alok. Yes, I definitely want to share the lessons learned here because this is going to be any customer may have these kind of questions or may see this problem. So some of the highlights here on the lessons learned. So importance of testing and also validating all pieces. Because whatever we get, whatever we see out of the box or the tool provides or the say, and then we need to be tested thoroughly and make sure so it works. What it says is what you see, right? So that's a very critical point of testing is very critical. And some of the data because I need to give an example. So if you're replicating data from DB2 mainframe DB2 data to the cloud, DB2 mainframe, most of the systems runs on the character code set is in EBCDIC. So when you go to EBCDIC to the UTF, Unicode, so then some of the characters will act differently. So it's nobody's fault, but that's what it is. So we need to test that thoroughly. So, and then if you talk second one, so need for additional workarounds to take a full advantage of Cloud Spanner. So what does that mean is, because right now, so Spanner, they keep adding more features and more is coming. Okay, Google is adding. And as of right now, what I remember is a lack of triggers and also there is no change data capture. So lack of triggers is so we need to find a way to do it. And we may need to have a other process to do the work like a trigger work. But if you don't, but the spanner doesn't have a CDC. What are the changes or you already have in the spanner? You want to replicate the data back to somewhere else. So there is no easy way. So that's one of things we need to keep that in mind. And if you go to next point, so the architectural diagram, architecture process. So we need because this is an evolving process, either Stream or Spanner or GCP, any product. So we are able to adopt and then evolve based on that. So we're able to flexible enough to change those architecture than what we are running on prem. And the final is that Google Cloud provides a flexibility to grow and quickly evolve to keep pace with changing needs. So that is true statement. Google is working with us very closely. They are very helpful, and so they did a lot of improvements for us, and they're still doing it. So that flexibility makes our project success. So this is one of the lessons learned, and also Stream does very good job of working with their vendors, with their customers, and then make the quick changes. So that adaptability will help us the digital transformation or the growth. So that's all I have for today. And over to Alok.
Great. Thank you so much, Neil. And I really appreciate you taking the time. And just as far as, the joint working together as partners, I think we were able to work with the product teams and with Neil's team. So, for example, when you saw maybe some of the current shortcomings or maybe things that are on the roadmap, like lack of triggers, we were able to, innovate there, make sure that we were able to take advantage of certain commit timestamps on the spanner table, populate those so that downstream applications could take advantage of that and then achieve what they were hoping to achieve. So we were able to satisfy that type of a solution. So with that, please feel free to reach me directly if you are interested in the technical details, as well as additional demos and also labs. So you can reach me at a look at Stream. And then I really enjoyed. Thank you, Neil, again, and I really enjoyed presenting to you today. And thank you very much for your time.